Hello, ho, 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 yes! And welcome to our Objective 14 notes. Now, Objective 14 says I can classify a correlation between variables and write the equation for a line of best fit over a set of data. We have been doing this a lot. We've already had a lot of experience with the line of best fit. We've done multiple activities in class. We've talked about it. Today, we're just going to kind of hit some points home, make sure we're solid and ready for our assessment later this week. So, we're going to start by defining some correlation vocabulary, all right? So a strong correlation is a correlation where the data is all near the line of best fit. And when we have a strong correlation, we know that our line of best fit, we can be pretty confident in that line of best fit and its ability to predict something that may occur, the accuracy of it. Now, on the other hand, a weak correlation tells us the data is not all near the line of best fit. So when we have a weak correlation, that tells us, yes, we can make the line of best fit, but we wouldn't be too confident using it to predict something. Now, a positive correlation occurs when the line of best fit has a positive slope. And that's to say, as one variable increases, the other one also increases. All right. The line of best fit would have a positive slope in that case, meaning that there's a positive correlation. Now, a negative correlation occurs when the line of best fit has a negative slope. All right, now, when the line of best fit has a negative slope, that means as our x variable increases, our y decreases, and vice versa, really, when you think about it that way. As one variable increases, the other variable decreases. That means there's a negative correlation between those lines. All right, and I went ahead and drew a little picture down here as well, kind of talking us through. So our strong positive correlation, we can see that this data all falls really neatly on that line. All right, and then we get into, I would still call this strong. We could use that to predict, but once we get here, we would have a weak correlation. All right, we'd say, ooh, where's this line of best fit? It might be right about there, but I wouldn't trust that too much. Then in the center, this is an example of no correlation, where I say, oh, is that the line of best fit? No. Maybe it's this way? No. And it would end up, mathematically speaking, it would be a horizontal line, which tells us that as one variable increases, we can't really predict what the other is going to do. All right, it's not affected by that. Then we have a weak negative correlation here, and then a strong negative, and then a very strong negative right here. All that data falls nicely on that line, okay? So, what I would like us to do now is I would like you to go ahead and match the following data sets to the appropriate correlation by writing the letter of the correlation that would be used to describe each graph. So there are 4 graphs here. I want you to identify one as strong positive, one as weak positive, one as strong negative, one as a weak negative correlation. All right, go ahead and pause the video, give it a shot. All right, so let's see how we did here. So looking at this first one, I'd recommend by starting, try to draw a line of best fit. This one I would say that line of best fit looks a little like that. I can see that all my data is pretty close to that line. So I would say this is a strong data set. The question is it weak or is it positive or negative? Now, since the slope of this line is negative, this would be a strong negative correlation. All right, looking at our next one, over one here, let's see. Drawing a line, oh, this is a little tougher. Line of best fit, maybe like that ish. So I can tell right away this is a weak correlation because I'm not too confident in my line of best fit. And then I see there's a positive slope though, so we're going to say that's a weak positive correlation. Next one here, very easy to draw a line of best fit. I can really just split those right down. All my data points very close, positive correlation. So we're going to say A, that's a strong positive. And then this last one here, I see a line of best fit. My data is not going to do too good touching it all though. We'll say that line of best fit there. And in this one, like I said, data's not too close to it all there, but it has a negative slope, so that would be a weak negative correlation. All right. If you have any questions over correlation, please raise your hand. I'd love to explain it further for you if you need it. Otherwise, let's move on to this task here. I want to do the first one together, and then I'll have you do the second on your own. So it says, draw the data on the coordinate plane provided that would have the stated correlation for the line of best fit equation given. So in this one it says the line of best fit is y equals 2/3 x plus 2. So let's go ahead and graph that. Plus 2 would be my y-intercept. The slope of 2/3 tells me up 2 over 3, up 2 over 3, up 2 over 3. And I can graph that line by connecting these dots here. Excellent. So there would be my line of best fit. Now my data is weak positive. Right? I have weak positive data, which means that I have a positive line of best fit. The slope of the line of best fit is positive, but my data is weak around it. So it's our job to draw data that would describe that. So I might draw data like, let's see, like this. You can see where they got the line of best fit from, but at that same time, we're not too confident in it. So that would be the data I would give for this line of best fit. It's definitely weak, positive, over that line of best fit. Why don't you try letter B? Go ahead and pause the video, try letter B, and we'll check that together. All right. So looking at letter B here, the line of best fit, y equals negative x plus 9. So my y-intercept of 9, I have a slope of negative 1, which means down 1, right 1. So I'm going to connect these dots here to create our line of best fit. There you go. Now our data is strong negative, so hopefully you put your data pretty darn close to this line, if not on it. Which you could totally do. You could say this is going to go here. This would be a very strong negative correlation. Obviously, they don't all need to touch. If you have data, off 1 or something, or maybe like a half off, that's totally fine. The important thing is that all that data is really close, so we can see that there's a strong correlation between these two variables. All right. So now that we've done that, we're going to expand on this idea, where we're going to draw the line of best fit over data provided and then approximate the equation of the line in slope-intercept form. So looking at letter A here, I see this data. First of all, I would call this data a strong positive correlation. Okay, so I'm going to draw a line of best fit that I think cuts right through this data. So let's say that right there. That's pretty darn good. All right, that's pretty darn good for sure. Excellent. So now let's approximate a line of best fit. So there's a lot of different ways to do this. The way that I recommend doing it is finding the furthest points that are on your line of best fit or creating points that are on your line of best fit. So I see this point here, which is the point 9, 9. And I see this point here, which is the point 0, 2. So I'm going to find the equation of the line that goes through 9, 9 and 0, 2. So in order to do that, I would need to find my slope. So we'll say this is x1, y1, and x2, y2. So my slope would be 9 minus 2 over 9 minus 0, which would become 7/9. So we'd say a slope of 7/9. And then I can see right here my y-intercept, 0, 2. Well, that would also count as my y-intercept. So I would write this equation as the line, y equals 7/9 x plus 2. And that's not an exact equation for this line, but remember this is an approximate equation. All right? An approximate equation for this positive, strong correlation here. All right, let's look at letter B. Let's try that one together. All right, so I'm looking at a negative correlation. This one I'd probably say is strong as well. Really, it's more of a moderate correlation here. Looking at a line of best fit, it's kind of tough for me to see, so that's why it's a little more moderate than normal. Oh goodness. I'd say this line of best fit is probably right about here, and it's going, I would say, through that. There we go. All right. Yeah. Very good. All right, so looking at it here, I see a couple points that fall on the line I drew. Let's see. We can use those points. Let's use this point here and this point here. So that would be the point 2, 6, and this is 6, 4. So let's find the slope here. X1, Y1, X2, Y2. So we'll say our slope equals y2, 4, minus y1, 6, over x2, 6, minus x1, 2. 4 minus 6 is negative 2. 6 minus 2 is 4. So we'll find a slope of negative 1/2. All right. Now, my y-intercept, I can't really tell what it is. It might be a decimal, it might be an integer. Remember, if we're ever in doubt of the y-intercept, we can solve it using that y equals mx plus b formula. All right. We just found our slope m. And then our points we can get from, our points can give us x and y, and we can solve for b. So let's use the point 2, 6 here. So I'm going to say y, or 6, equals m, negative 1/2, x, or 2, plus b. And then I can solve for b this way. So negative 1/2 times 2 would just be negative 1. Then I can add 1 to both sides. 6 plus 1 is 7. So b equals 7. So my equation then would be y equals negative 1/2 x plus 7. Fantastic. All right. Shall we try some on our own? Why don't you go ahead and take a shot with letter C? Go ahead and try letter C on your own. Pause the video, and then we'll check that together. Go ahead and try letter C. All right, let's see how we did here. So I'm looking at it, and I really see a line of best fit cutting right through here almost. I think that's a good line of best fit. Now remember, your line of best fit might not exactly match mine. As long as they're close, I'm going to count it. Don't you worry. All right, so I see, let's see. I like this point here, 1, 1, and we'll go this point here, 10, 6. So coordinate points 1, 1, coordinate point 10, 6. And let's do this here. So we'll say this is x1, y1, and x2, y2. So we'll say y2, 6, minus y1, 1, over x2, 10, minus x1, 1. 6 minus 1 is 5. 10 minus 1 is 9. So a slope of 5/9. Woof. All right. Now I'll use y equals mx plus b. Pick a point. I'm just going to use 1, 1 here. I think it'll be a little easier. So 1 equals 5/9 of 1 plus b. What is 5/9 times 1? Well, it's just 5/9, of course. Anything times 1 is just itself. 1 minus 5/9. Think about this is 9 over 9 minus 5 over 9, which would give me 4/9. So b equals 4/9. So my equation that I found was y equals 5/9 x plus 4/9. Now again, your equation might be a little different, and that's okay. All right, as long as it has a similar slope, 5/9, maybe you did 1/2. Maybe a y-intercept was 1/2. Maybe it was 1. Or maybe it was 0 even. Really, what matters is that you got this slope close and a y-intercept close, because remember, this line is an approximation. It's not exact. There is a way to calculate the exact line of best fit. That involves a graphing calculator, though, so we're not going to get into that right now. All right. With that being said, letter C done. Why don't you try letter D on your own? Go ahead and give that a shot, and we'll see how we do. All right, letter D. All right, looking at letter D, let's see what we have here. All right, so letter D, all right, line of best fit. Definitely a strong negative correlation. It's kind of hard to see where this line of best fit's going to fall, though. I think it's going to fall pretty close to here. Pretty confident with that. All right, so let's see. Now, this is one of those situations where it goes right on a point, but the data's not there. I'm still going to use this point. What is that? That's 9, 5. I'm going to use that point, and then it's right on this point here, 1, 1. Beautiful. All right, so let's use those. Oh, sorry, 9, 1, or 1, 9. Fool. All right, so we'll say x1, y1, x2, y2. So we'll say our slope is y2, 5 minus y1, 9 over x2, 9. That's 1, 1. 5 minus 9 would be negative 4. 9 minus 1 is 8, so we found our slope to be negative 1/2. Fantastic. Now I can use y equals mx plus b, plug in some points here. I'm going to use the point 1, 9, so I'd say 9 equals m, negative 1/2, x, 1 plus b. Well, negative 1/2 times 1 is just negative 1/2 plus b. So I need to add a half, so remember this would be 18 halves plus 1/2 equals b. 18 plus 1 tells me that b equals 19 over 2. So my equation would be y equals negative 1/2 x plus 19 halves. And again, yours might not exactly match that. That's okay. Again, we're approximating the line of best fit now. Really what this is about is we're practicing drawing lines, given a couple of points. We're looking great. All right. All right. Y equals negative 1/2 x plus 19 halves. Very nice. All right. Couple more. Why don't you try letter E on your own? Go ahead and try letter E. Pause the video, give that a shot, and we'll see how we do here. Letter E. All right, let's check out letter E here. So I'm looking for a line of best fit. This one is a much weaker correlation. So our line of best fit isn't going to perfectly capture a lot of this data, but I will go ahead and say it looks a bit like that. So I see this point here, 0, 1. I'm going to use it. It's really close to my line. And, goodness, it's really not another pretty point that I'd like here. Let's use this point. Again, it's not a data point, but my line pretty much is right on it. That's the point 8, 7. All right, so let's find the slope between those. So we have x1, y1, and x2 and y2. So we'll say my slope y2, 7 minus y1, 1 over x2, 8 minus x1, 0. Well, 7 minus 1 is 6 over 8. When I simplify that, my slope will become 3/4. Now I'm going to use the point 8, 7 here for my line for y equals mx plus b, so I can find my x. Oh, wait. I don't need to use a point. Why do I not need to use a point? 0, 1 would tell me my y-intercept, right? That tells me right there, b equals 1. So with that, I would say my equation is y equals 3/4 x plus 1. Now, again, if you got a different one, that's fine. If you're not sure if it's right, feel free to raise your hand, and I'll check to make sure that how you got your equations accurate. We're looking for a slope close to 3/4 and a y-intercept close to 1. All right. Letter F. Letter F. Why don't you try letter F on your own? It'll be the last one of these we'll do. Go ahead and try letter F on your own, and then we'll check it together, all right? Letter F on your own. Give it a shot. All right. Looking at letter F. This one, weak correlation here. Definitely hard to see exactly where everything's going. So my line of best fit looks a little something like this, I think. Yeah, I'm pretty confident in that. All right, so I'm looking for points that line of best fit is nice and close to. So I'd say this point is pretty close to, and I'd say this point here is pretty close to. So this is the point, let's see, 1, 7. This is the point 10, 2. All right, so let's find the slope for this line between 1, 7 and 10, 2. So we have x1, y1, we got x2, y2. So we'll say y2 2 minus y1, 7 over x2, 10 minus x1, 1. 2 minus 7 is negative 5. 10 minus 1 is 9. So I found a slope of negative 5 over 9. Gross. So now I'm going to use the equation y equals mx plus b. I'm going to use this point here, 1, 7. I don't have a y-intercept that I can really approximate. So I will say 7y equals m, negative 5 ninths, times x, 1, plus b. So that means 7 is negative 5 ninths plus b, because negative 5 ninths times 1 is just negative 5 ninths. And then I would add 5 ninths to both sides. Now 7, let's see, that'd be 7 times 9 is 63 ninths plus 5 ninths. So that would tell me that b is 68 over 9. All right, so my equation would be y equals negative 5 ninths x plus 68 over 9. Okay, and again, if yours is not exactly that, that's fine. As long as you got a slope close to negative 5 ninths, you know, negative 1/2 maybe, as long as you got a y-intercept close to 68 ninths, which as a decimal would be around 7.6. So if you want to look and plug that y-intercept in, see if you got something close to 7.6, that would be fine. All right, hopefully we're feeling confident with these. Let me know if you have any questions. What we're going to do now is we're going to do some applications, and this is where this data gets used a lot in analyzing scatter plots, linear data, and using them for predictions, all right? So looking at number 1, the data below demonstrates the daily average of ice cream sales for Victor's frozen flavors in regards to the average monthly temperatures. Find an equation for the line of best fit, then using your equation, predict the amount of daily sales Victor should estimate if the temperature is 21 degrees Celsius. Okay, so line of best fit comes up first. Let's just draw this on here. Let's see. Yeah, I'd say that looks pretty good. Let's have it go ahead and cross right through here. No, I don't like that. So notice how I only have 1 point below the line. Everything else is above it. That means this line of best fit isn't very accurate. So we're going to try it again. And that's totally fine if it takes multiple times to get a better line of best fit. I need one that's not so steep. There we go. That's better. That's a better line of best fit. Very nice. Okay, so let's approximate an equation here. So I'm looking, I see this point, 0, let's see, that's 10, 100. Notice my scale here, this starts at 10. 20, oh, look at this one, 22, 500. Beautiful. So 22, 500 and 10, 100. Excellent. All right, so to find the equation, I need to find the slope of this line, x1, y1, x2, y2. So I'd say my slope is y2, 500, minus y1, 100, over x2, 22, minus x1, 10. Now, 500 minus 100 is 400, 22 minus 10 is 12. 400 divided by 12. I'm not too sure on that one, to be entirely honest. Calculator here, 400 divided by 12 equals 33.333 repeating, okay? You can use decimals here, that's totally fine. If I wanted to simplify this, that'd be 100 over 3, right? I could take a 4 out of everything here. So 100 over 3, let's do that. So my equation, or my slope, would equal 100 over 3. Very good. Now my y-intercept is what I need to find next. So let's, oh goodness, let's use this point x1, y1 here. So with that, I'm going to do it over here. So I'll say y, 100, equals m, 100 over 3, times x1, which is 10, plus b. Gross. So I'm going to have 100 equals, let's see here, 100 over 3 times 10. So that would be 1,000 over 3 plus b. So if I multiply everything times 3, that'll get rid of this fraction here. So I'd have 300 equals 1,000 plus 3b. Subtract the 1,000 from both sides, minus 1,000. 300 minus 1,000 would be negative 700 equals 3b. Divide by 3, divide by 3. And I'm totally fine just saying b is negative 700 over 3. Using some nice fractions here. So my slope, my equation. I have my slope, I have my y-intercept. My equation then would be y equals 100 over 3 x minus 700 over 3, which is to say, if there was a 0 degrees temperature, they would not be making any money. No one's probably buying frozen flavors when it's freezing outside. All right, so now estimate. This is one where the graph is really helpful. We want to estimate when it's 21 degrees Celsius. Yes, I could totally plug 21 in for x and solve it that way. We could do that. However, notice on my graph, 21 would be right here. So let's create this vertical line where 21 is, and then we can approximate that value. So this is my data point here. Let's see, that looks to be between 400 and 500. My estimate looks to be just a little more than half. I'm going to say $465. That would be my estimate there. Now, if we wanted, we could totally plug this into our calculator to get a better idea. So we'd have 100 times 21, and then we would divide that by 3. 700 minus 700 divided by 3, and we would get $466.66. Look at how accurate we are. That's awesome. So that confirms a couple things. One, that confirms our line of best fit's pretty close, and two, the equation for that line of best fit is accurate. Excellent. All right, let's get back into the problems here. Let's look at number 2 now. The data below, I'm going to sneeze. Ooh, darn. Here it comes. No, it's not. I'm not going to do it. The data below represents... Darn it! I'm sorry, guys. The data below represents the amount of visitors at Big Beach in Maui depending on the average daily temperature. Complete the following tasks. A, find the slope. All right. Let's find the slope. Well, let's draw a line of best fit first, shall we? So it looks like this line of best fit would be cutting right through here, I would say. That's a pretty good line. Got a pretty even amount of space on either side of the line. Notice it goes pretty much right through this point. Let's see here. It also goes almost right through that point. I don't know what just happened there. That scared me. Alright, let's try that again. Sorry. It goes about right through this point here. That would be 96,600. That data point's pretty hard to read. We could approximate it. It's 82. Goodness. What would we say that is? Maybe a fourth of the way between 75 and 150, so maybe 95, we'll say. Sorry, let's redraw this line here. So we'll say this is 82, 95. All right, so let's find the slope here. Like I said, we're approximating. We're probably going to get some ugly numbers. That's okay. X1, Y1, X2, Y2. So my slope, Y2, 600 minus Y1, 95 over X2, 96 over X1, 80, or minus X1, 82. So 600 minus 95 would be 505. 92 minus 62 would be 14. 505 over 14 would be my slope. Has a decimal. Let's see about what that equals. So 505 divided by 14 equals 36.07. Okay. Find the y-intercept of the data. Ooh. All right. Well, this is one where I actually might use that decimal here. Find the y-intercept. Notice graphically we have a huge break in this graph, 0 to 80, so we really can't guess it based on the graph that we have. All right. So finding our y-intercept, we can plug in a point. Let's use y equals mx plus b. Let's use this point that was really close to our graph, 96, 600. So we'd say y 600 equals m 36.07 times 96 and then plus b. So in my calculator I'll need to do 36.07 times 96. When I do that I get 3,462.72. So 600, 3,000, what was it? 462.72. I can subtract both of those. When I do that in my calculator, I get 600 minus 3,462.72, negative 2,862.72. So we'd say that B equals negative 2,862.72. 862.72. And then it asks us use the information from A into B to write our equation for the line of best fit. So we'd say y equals 36.07x minus 2,862.72. And there we go. So that's to say if it was 0 degrees outside, there'd be negative people at this beach, which I don't know if that's entirely accurate, but it's understandable, right? I don't think anyone's going to a beach when it's 0 degrees outside. All right, looking at letter D, does the data have a positive or negative correlation? Why does that make sense? Well, the data has a positive correlation. We can see that because the line has a slope that's positive. Why does that make sense? Well, think about it in the context here. How does, as the temperature gets higher, do you think more or less people want to go to a beach? More people. So we can say as temperature increases, more people go to the beach. That makes sense, right? As it gets hotter, more people are like, oh, it'd be nice to take a dip at Big Beach here on Maui. All right. Let me know if you have any questions. We're going to do one more. I'm going to let you do this one on your own. So go ahead and try number 3 on your own. Last one we'll do today. Give it a shot, and then we'll check it out. All right, so this one's a little tougher, all right, because we don't have those lines, we don't have those small marks that are helping us guide us a little bit better. That being said, let's draw a line of best fit through all of this. So if I'm looking at the line of best fit, I definitely see a negative correlation. It's not very strong, but I would say it's a little bit like that. All right, so now let's look at some points. I see 35 is really close to 500. I see, let's see, 65, not quite. Oh, I'd say 85 is pretty close to 300, so let's use that. So we'll say, notice that this is, now that I actually see it, this is really splitting this almost perfectly. So let's say this is 30, comma 500, and let's say this is 85, comma 300. All right. So, again, if you use different points, you're going to get different answers, and chances are you use different points. That's okay, all right? Again, we're approximating equations here. All right, so to find the equation, I need to find the slope. So we'll say this is x1, y1, and this is x2, y2. So y2, 300, minus y1, 500, over x2, 85, minus x1, 30. So we would get negative 200 over 55, which I can take a 5 out of everything, so that'd be negative, let's see, negative 40 over 11. So we'll say our slope is negative 40 over 11. Now our y-intercept, Oh, darn it, our graph only goes to 15. Well, that makes sense. They're not going to have data for people who are 0 years old driving. All right, so let's approximate our y-intercept here. Let's see, negative 40 over 100. Let's figure out what that is as a decimal. So negative 40 divided by 11, negative 3.64. So we'll say m is negative 3.64. And then let's use a point here. Let's use 3,500. So we'll say y 500 equals m negative 3.64 times 30 plus b. Ooh, I should have given myself more space right there. So let's multiply negative 3.64 times 30. When I do that, I get negative 109.1. Okay, so negative 109.1 plus b. I can add 109.1 to both sides. Which tells me that 609.1 would equal b. So my equation would be y equals negative 3.64x plus 609.1. All right, now what'd you say here? Does the data have a positive or negative correlation? I think I mentioned it earlier. All right, this data clearly has a negative correlation. Why does that make sense? All right, well, as drivers get older, their vision goes down, right? As age increases, vision gets worse. And that's why it makes sense. As your age goes up, your eyesight isn't as good. All right, now remember, if you got a different equation, that's fine. As long as it's somewhat close to this, no worries. This is all a practice, writing the equation of lines, using it in some data. I hope you all had fun. This is what we're going to stop with today. We'll have some practice problems, assessment later this week. Mr. Carter signing off. I will see you next time.